Solving monic quadratic equations by factorising. In earlier work, we looked at factorising quadratics. A quadratic equation is one that can be written in the form x squared plus bx plus c equals 0. Actually, more generally, that would be ax squared plus bx plus c equals 0. But here we're dealing with the situation where a is 1 because we're looking at monic quadratics. Before you try to solve quadratics, you should have them written in this format, and then you should try to factorise. At least if we're solving by factorising, there are other methods of solution, but in actual fact, all the methods of solution usually start with writing them in this format, or in this format if they're monic. You will then have something of the form x minus p, x minus q is equal to 0. To solve from here, we need to utilise the null factor law. The null factor law says that if a times b is equal to 0, then either a is equal to 0 or b is equal to 0. They could both be 0 in some circumstances. So if x minus p, x minus q equals 0, then either we need x minus p to be 0, or we need the contents of this bracket, x minus q, to be 0. So what we're saying is x minus p is 0, or x minus q equals 0. If x minus p is 0, it should be fairly clear to you that x must be equal to p, because p minus p is 0. And if x minus q is 0, it should be fairly clear to you that x would be equal to q. So we get the answers x is p or x is q. This is reasonably straightforward. If we have x plus 2, x minus 5 is equal to 0, then either the contents of this bracket are 0 or the contents of this bracket are 0. So what would x be to make the contents of this bracket 0? Should be fairly clear that x equals negative 2 will do that. So all we're doing there is changing the sign here. For the second bracket, it should be clear that x equals 5 will make that bracket 0. Then we have 5 minus 5 in the bracket. And once again, you can get that by changing the sign just there.